Hi there. Okay, I just want to show you a few examples on estimating. It's pretty straightforward usually. You round to one significant figure, and then any number that you've got in your calculation that isn't already one significant figure, and then you do your calculation. But let's start with something that's a little bit trickier, which is the square root of 30. It's already at one significant figure, and we know that 30 isn't a square number, so it isn't straightforward to find. So there's some steps you can take to actually give you a decent estimation of this. Usually, they will ask you to estimate a square root to one decimal place. Okay, so they want some form of accuracy there. So let's just start by breaking this down into what we know about square numbers. The square number to the left of 30 is 25, and the square number to the right of 30 on the number line is 36. So we know the square root of 30 must lie between 25 and 36. So let's actually draw ourselves a number line for those two locations, starting with the square root of 25, and then we're going to go all the way up to the square root of 36. Now, let's think about this. We want this to be in tenths, so let's go up 10 even spaces. So we'll go to 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe the line's just there. That will be the square root of 36. So we've got 5 being the square root of 25 and 6 being the square root of 36. So we know the square root of 30 lies somewhere between there. Let's just double check this to make sure. 5.1, 5.2, 5.3, 5.4, 5, 6, 7, 8, 9, and then 6. Okay. So we might assume that just by guessing, I guess, that it's just going to be less than half. Just less than half, because 30 is pretty much, it's 6 less than 36 and 5 more than 25. So we know it's going to be around here somewhere. But there is a nice way of actually trying to figure out to a high degree of accuracy how you can get this to one decimal place. But taking into account that you're going to have to be rounding from a second decimal place to get it to one decimal place, if I were to put this into the calculator. So let's just think about the square root of these numbers. So to go from 25 to 36, that's got a range of 11. So what I'm thinking about is how far through that range of 11 have I got to go to get to the square root of 30? The distance to here is 5. The distance all the way to here is 11. So I want 5/11ths of this distance. And we know in decimals that that is equal to 10 tenths. From 5 to 6, that's 10 tenths. So I want 5/11ths of these 10 tenths, and I want to add that on to the number 5. So that would give me a decent estimation of what this square root is. So let's think about that as a calculation. I want 5/11ths of my 10 tenths. Okay. So let's see if we can simplify this. Remember, we're not supposed to be using calculators, so I'm not just going to throw it into a calculator. 5 times 10 is 50. 50 over 11, well, that's the same as 4 and 6/11ths. Sorry, is it? Yeah, it's 6/11ths. So I've got 4 tenths, and then I've got 6/11ths of a tenth. Now, is that more than half a tenth or less than half a tenth? Now, I think that is definitely more than half a tenth. 5.5/11ths would be half a tenth. So I've got 5.4 and then something that's bigger than half a tenth, so that means I would have to round this up to 5.5. So I've got my 5, I've got 5.4, and then I've got 6/11ths of a tenth, which is going to be greater than a 5. So whatever this number is, it's going to be greater than 5. We could probably try and estimate what 6/11ths is by just doing a division sign, doing your bus stop. But we don't need to do that. We just know that this bit is bigger than a 5. So this next number that's coming is going to be bigger than 5. So therefore, we're going to say that the square root of 30 is greater than 5.45, but it's going to be less than 5.5. So we know it's going to be 1, 2, 3, 4, 5. It's going to be around about here. Okay, just under the 5.5 mark. So we round it up. So the square root of 30 equals 5.5 to 1 decimal place. Okay. You know, a lot of time you're just going to estimate it anyway. If you know it's really, really close to one of these decimal points, then you're going to be rounding that nice and easily. Okay. But this bit here is a nice way of estimating it. Okay. For the second example, we could chuck it into our calculator, see how close we are actually. Let's have a look. Square root of 30. 5.477. And then we've got 225575, so it doesn't really matter that bit. But it's the 7 bit. So we knew it was 5.4, we got the 4 tenths, and then this must be equal to 0.077, roughly. Okay, let's have a look at the second question. I want to square root this calculation, estimate this calculation. And it's the square root of 2.85 plus 5.91 divided by 0.22 squared. So what I need to do here is round everything again, so that's what I will do. This is approximately equal to, okay, when we're estimating, we can use this sign because it tells us it's approximately equal to the square root. So 2.85 gets rounded to 3 because that's one significant figure, plus 5.91 to one significant figure is 6. And then 0.22 to one significant figure is 0.2, and that's all squared. So we know that this is going to be equal to the square root of 9 divided by 0.04, because 0.2 squared is, I basically do 2 times 2, and I get 4, and then there's 2 numbers after my decimal point, so the 4 is the second number after my decimal point. So first of all, I've got to do the fraction calculation. So 9 divided by 0.04. Let's just do that separately over here. I don't like dividing by decimals, so what I'm going to do is times the numerator and the denominator by 100. So I get 900 divided by 4. Okay, because now that's an equivalent fraction and much easier to do. 900 divided by 4 is the same as 450 divided by 2. 450 divided by 2, well, that's just 225. So my calculation now is not 9 over 0.04, but it's the square root of 225. And we should know our square numbers by now. If not, we just need to go up and try them out. 10 squared is 100, 11 squared 121, 12 squared 144, 13 squared 169, 14 squared 196, and 15 squared is 225. So the answer is 15. Now you might get asked to decide, basically explain, do you think this is an overestimate or an underestimate? So from that, you need to look at where you've been rounding and what you've rounded. Okay. So let's think about this fraction. Okay, I've rounded this number up, 2.85. I've rounded 5.91 up. So essentially, the numerator has been rounded up. With the denominator, we round down to 0.2. Now think about what happens with a fraction when you make the numerator bigger and the denominator smaller. If I were to make the numerator bigger, let's say I kept the denominator the same, then I'd be increasing the number. If I were to keep the numerator the same and decrease or change the denominator, then I'd either be making it bigger or smaller. But if I'm going to round this denominator down, then I'm going to make the number bigger. If I'm going to round the numerator up, I'm going to make the number bigger. So this is a over estimate. Okay, so sometimes you will get asked to explain why you think it's an overestimate, and you might say because the numerator is rounded up and denominator rounded down. Okay, so that's the basics of work doing estimation. You make sure you round to one significant figure, every single number you use. So let's have a look at one where they might actually give you a little bit of a problem. So with this one, I want you to estimate the volume of the wedge. Okay, so that means all my numbers get rounded to one significant figure. So 4.2 becomes 4, 21 becomes 20, and 10.8 becomes 10. Okay, not 11. Although sometimes, if you have a calculation, it might ask you to approximate something. They're sometimes quite happy for you to round to 2 decimal places, or 2 significant figures, sorry. Okay, so here, if we're going to work out the volume, we're going to need the area of this sector. Okay, so the formula that we use for area and working out the area of a sector is the area of the circle times by the portion of the circle you've got, which is 21 degrees of 360. But don't forget, we're going to round this to 20. So the area is going to be of sector is going to be equal to 20 over 360. Actually, 360 can be rounded to 400 because you're allowed to do that. Then I'm timesing that by the area, the formula for the area of a circle, which is pi times the radius squared. Okay, so let's actually look at this now. Let's start properly rounding some of these. So it's 20 divided by 400 times by pi, which is rounded to 3, times by the radius, which is 10.8, but now we're going to round that to 10, so we're going to times that by 10 squared. Okay, so let's have a look, see what we get here. We get 20 times 3, which is 60, times by 100, which is 6,000, divided by 400. Okay, and this will get us the area of the sector. So cancel out the zeros, nice and easy. 60 divided by 4 equals 15. So I've got 15 centimeters squared for an estimate for the area of the sector. Then all we need to do to work out the volume is just like a cylinder. We times it by its height. We know the height to be 4.2. So the volume of wedge equals 15 times 4, because it's 4.2 high, and actually it's just going to cancel out this divide by 4 earlier, which equals 60 centimeters cubed. Alright, they may bring in questions where you're working out areas, you're working out percentages and stuff, but you just still have to estimate by rounding to one significant figure. If it makes your life easier, actually, if you're doing a proper square root of something, and it would be nicer if you just rounded it to 2 significant figures, then I would do that if you get a really nice answer from it. Okay, right. Thank you very much. Have a go at the worksheet. Don't upset you, and then you can practice some of this. All right. Cheers.